Good morning. Today I'm going to be looking at Diesel, which is, as you can see, safe and extensible ORM and query builder for Rust. Um, the application I'm sort of orienting this around is an API gateway that will eventually have a GraphQL interface, but to supply data for that, I'm going to be using this to pull information out of the database. So Diesel comes with a few nice features, like it'll generate these table macros, which look like, here we are, which binds to the different columns within an SQL database so you can query against it. It also comes with migrations. However, I'm using this for databases that already exist. They've been in production for years at this point. So I don't really need, well, I'm already managing the migrations using Rails migrations, which have been working pretty well so far, and I'll probably stick with those. But it is nice to know that if you're starting from scratch and you do choose to go with Diesel, that you do have this built in. All right, as I mentioned, Diesel will generate these table representations, the schemas. However, you do need to have these models, which are what the results from a given query will be mapped to. This isn't ideal for me because, as I said, I already have these tables in production, and they are quite extensive, and I don't really want to be writing all of these. Luckily, in this thread, I did, or somebody did post, D. Erickson, or Sebastian Santoro, I don't know what Direxon means, but whatever, posted this Diesel CLI extension library, which does include a number of things, which so it has the models, and then it also has these generates protobufs. Not sure what a conversion implementation is, but I'm going to be mostly working with the model Rust structs today. So, all right, let's follow the guide and let's get started. All right, so start by generating a new project. I'm going to call it the gateway. It's a binary. Okay. Nope, not in there yet. All right, builds hello world. So I've already got the Rust language server and the Rust debugging setup, but if you want to set that up yourself, I believe it was this. Yeah, this article was really helpful. So it's Forest the Woods, how to debug with Rust, or debug Rust with Visual Studio Code. This was super helpful, and it basically worked right away. Okay, so we've got that set up, got it going. All right, let's start by installing CLI. While I'm doing that, I'm going to install the dependencies in the project. So this says 1.0, but the newest version is 1.4.2. So we're going to use that latest version instead. Also, as listed here, I'm going to include the Postgres feature since that's the database that I'll be using. Let's get some space around here. Then we're also using .env. This is how the getting started guide loads in your database connection information. 1.9.0. Pretty sure that's not the newest one. The newest one is 14.1. Okay. Cool. Separate CLI tool. Generate. Okay. So we didn't see this error. Oh, I've already got installed, so we didn't see that. But I've already installed this. But you'll need to install whatever client libraries you're using. I believe that Postgres and MySQL are default, but you can specify which ones you want to use here. Okay, so this is just setting the database URL inside the env file, which is loaded by .env. So let's just do that. And then I'm going to edit that to work with the database I already have that already exists. So username is Postgres, no password, it's local, and it's running on that port, bookstore. All right, so let's make sure that that database is running. So I'm going to go over to the bookstore project, compose, start the bookstore. Right, it's running. So we've got the database up and running. So let's do Diesel setup. And it looks like this just creates the migrations folder. Like I said, I'm not using the migrations with Diesel. I'm using it against an already existing project, so I'm not going to include that directory. Okay, well, now that I've got my dependencies installed, I'm going to start generating some code. So let's look over at this CLI project. Okay, so I need to have this installed. So let's do cargo install which is already installed, so we don't have to run it again. So let's get the schema going. So we're going to print the schema out into source schema rs. All right, so this table isn't compatible with Diesel because it doesn't have a primary key. This one in particular is the migrations table, which Rails uses to tell what migration was the most recently run. So you can either roll back or play forward if you haven't run all the migrations yet. So we need to have a way to exempt all of these. So let's take a look at this. So Diesel actually lets you filter out individual tables. Let's see. So there's filter. I'll do accept tables. This is an array. Diesel only supports tables with primary keys. Oh, okay. This is a join table, right? So I think this, if we look at this table, it would only have 2 columns in it, which is like the foreign keys for the different tables. So for now, in the future, we'd have to deal with this somehow, right? We can't just ignore all the join tables when we're trying to query the database. So, but for now, I just want to like connect and print out a row, right? So let's actually exclude this one as well. Okay, it looks like we've got another one. And there's actually like several of these tables, so I'm actually gonna skip ahead and just remove several of these tables from options at once. So um, don't want to hold you in suspense, but there's quite a few of these. Okay. Right. Let's see if I got them all. Right. Let's see what comes out. Yeah, so as I mentioned before, we've got all of the sort of table macros here, mapping the columns to some struct type that's a Rust value. So later on we can serialize them into our models. Okay, so next thing we're going to do is generate our models. So here, I'm going to do Diesel ext src models. Okay. Right, so we've got some warnings here, but it looks like the models were generated. Let's see. Ah, here we are. So let's just uncomment these because array is a valid type. We just might have to import some additional structs. So we're not getting any feedback on this file. So maybe we need to now that we've got our code generated, we can try to actually load something in from the database. We've got this established connection function, but I'm just going to do everything in the main file for now because I don't feel like working with a bunch of different files if I don't have to. All right, let's turn create diesel. And then we're going to be using .env. I'm not sure what this prelude is, so I'm going to leave it out until it comes up. Connection. NV. Okay, so we're also going to be using the modules we have here. So we've got models and we've got schema, and then use schema spree product. Look this up because it's a little bit much. So it's actually spree products DSL star. So I'm not exactly sure what this structure looks like. It's generated by the tables macro, and I haven't gone into the documentation for that macro, so I don't know exactly what this is generating, but I do know that this will allow me to actually read from the table. All right, but to get the connection, so .env, okay, get the database URL from the env now. Not a lot of trouble there. Okay, so we get the connection. Last time I tried to use it for Rust was not great. Maybe there's been some serious improvements with the RLS server, or just the plugins are a lot better. Not sure, but it's probably a combination of both, and people have been doing a lot of really good work on it. So that's pretty great. Okay. Semicolon. All right. So we've got our connection now. Let's see what it looks like to query from this. Right. So this is what we generated before, right? But this is this guide is recommending that you sort of create them manually. I do not like the prospect of doing that. I like to have one source of truth, and to me, that's the database, right? It shouldn't be the table definition. It shouldn't be, or sorry, the table definition or this model. Like, if possible, you should be able to generate everything from the database. And which is nice because, like, if your generator changes, or at least like in Rust, it's not too bad because if the generator changes, outputs different code, then at least like you'll have some compile time notification that like this type has changed or whatever. Whereas like in Ruby, for example, like you'd have to have a comprehensive test suite that was really solid and test all these edge cases to deal with something that a type system should get. But anyway, let's get the post. All right, so we're actually getting to like where we're starting to query now. This example is a little bit confusing because it loads in the schema from this external crate, which we are absolutely not doing. It's right there. So this is where this DSL star comes from. So we're just gonna do a single. No, let's do a couple products, literally a couple. We're gonna go spree products. Anyway, so let's limit 2. Just gonna do 2 now, and then we're gonna load spree product through the connection, and then if it doesn't work, products. Okay, cool. Then we're gonna loop over the product in results. Print post at ID, and then we're gonna do the name. Let's try to build and run. All right, reached recursion limit. Oh yeah, so these macros require a lot a lot of stack space to expand out, so gotta add some settings to the main file. I'm actually going to set this to 512 because I don't want to come back again. Okay, starting to get somewhere. So chrono does not exist. So I guess we got to install the chrono library. Chrono version. Latest version is this. Should be ready to go. So then we go to our main file, extern create chrono. What about now? Okay, big decimal. So I think that's another package we need to install. All right, there we go, 1.0. Well, maybe big decimal was perfected in this 0.1 version, but well, I guess we'll just keep going with it. All right, include that here. No, to do stern create big decimal. All right, run. Yeah, so we're getting some compiler errors here, but I think that's, yeah, it looks like that's because we're not successfully compiling here, so it's not loading those in. So it looks like we need to include or to use some additional types. I believe it's a Diesel type, so let's see, Diesel SQL, nope, SQL types. We got float, 8, array, int 4, okay. Oh, we've still got this unknown type here, but we've just included float 8. So let's do 747. right here, nullable is option. So we should be good with that. Let's try compiling again. Okay, it's not building yet. This is a little bit more difficult. So trait selectable expression is not implemented. So I'm not positive what, so it's spree users and spree orders. I think it would take a little bit to track down this. It looks like it's having trouble with varchar. Not sure. I'm gonna comment those out for now. Now you can see that how long it takes for the RLS server to actually update. I'm not even positive that it is updating for this. So let's run it again. So this is not going away. Oh, it's not nullable. Okay, and that should go away now. What's this one? Naive date. Maybe it just needs to be imported. Yeah, there we go. Ah, I didn't. So it's still referencing the spree orders, and then spree users tables here. So I'll just comment them out down here as well. Oh, this must be where that Diesel prelude stuff comes in. I didn't include that earlier. Whatever. Yeah, that's what it was. Okay, so that is coming in correctly now. Schema seems to be building. Let's try and do it. Still not happy. Find post. Okay, so now we're getting a little bit more detail. Okay, so there is a serialization deserialization dependency. So if we check out, so what I mean by that is like, it's not a problem in the source code. Chrono and Diesel have some additional features that need to be turned on. So here, if we add Chrono to the Diesel features along with Postgres, and then in Chrono we add the third serialization deserialization feature. Why is that highlighting differently? Does it need a space? Should get a bit different response. And compile. Post name. Maybe I just named it wrong in the main file. Yeah, okay, because it's product. Okay. All right, we've got some results. It's a little messy, so let's actually get these into the same line. Actually use the fact that it's formatting. Instead of printing them out like a barbarian. Man, these compiler warnings linger for a long time. Yeah, I attribute that to just like the Rust language server being a little slow. I think it's because it has to recompile the whole program and then sends all the and then it sends all of the errors back in, rather than like for example the IDE for IntelliJ will compile only portions of the application or portions of the program, so that like its response time is much faster. So you can, I guess that must be why like this maybe it can't handle macros as well, so I can't get auto completion in this macro module, which is not a deal breaker, right? Like you can always look up documentation and kind of try to figure it out, and like worst comes to worst, like you kind of just have to bang your head against the compiler for a while. But like autocomplete is a real time saver for me, right? Like if you have like strong type definitions, it should be pretty easy to um, explore a library, especially like if you can get documentation for it. Like this isn't ideal. Like ideally there would be more, but this like what would it be generated from? But like for example, like for PG connection, yeah. So we get a good amount of documentation here, and now that we have all those, yeah, we have establish in here. Is this the only one? I guess that's the only one. Yeah, so like having those here and like being able to look up what each one of these does in line saves a lot of time, right? Like you don't need an internet connection to do that. I mean, assuming you have the libraries downloaded already. This is taking a long. Oh, it wasn't running, so that's funny. Yeah, this is odd because these are definitely being used. Okay, yeah, it's printing out each line. Looks good. So overall, like Diesel works well. It's not too difficult to debug some of these issues, but you do have to be willing to, read through feature requests to find the extensions and like go through a lot of GitHub issues because the documentation for it is really limited compared to more mature libraries. Again, I'm going to reference the Java ecosystem because that's what I've been working in a lot lately. The Juke library would be similar to what you're getting here, where you can generate the database schema representation in Java and then query against it, right? And that makes writing database queries really, really easy. We didn't get into actually writing some complex queries here. That's just gonna have to wait till another time. It took long enough to get the database connection set up, and I think frankly like made enough progress, even though we had to sort of back off a couple of these. I'm sure that like these could be fixed by including the right serialization library, but I'm just gonna punt on that for now. I guess like a verdict is like if you're using Rust and you want to have like a sophisticated database interaction and you need to have like a higher level representation of your data, this is a great option, especially with the extension generator. I love code generators, like even if the code is messy, right? Like you can basically treat it, I mean, you should treat it as a library, the code that's generated, and it can save you a ton of time. And I don't know, using Rust is always an attractive option because of its speed and safety guarantees. Oh yeah, one more thing I wanted to look at was the size of the produced binary. So let's do cargo build production. Oh, build. Right. So previously, like the Java, as I mentioned, this is looking at it for the use as like an API gateway, and I initially tried to run the Java application in a Lambda from AWS. The problem was that it took way too long to actually get the Lambda up and running. Like up to I think 15 seconds was how long it took. So you would make a request and then 15 seconds later you get your first response. I mean, it scaled awesomely, but that first request was always very slow. Actually, so what is the production? what is the release? There we go. Cargo build release. Okay. So yeah, the artifact for the Java application, which like after quite a bit of work pruning out unused libraries or segments of libraries that weren't being used, um, I was able to get the artifact down to I think 20 megabytes, which on its own took a bit, or took about I think 15 seconds to upload to AWS. Like once it's inside of the or once it's on S3, it shouldn't take that long to transfer over to the Lambda since it's within their network and it's not, over the internet. But still, like cutting down on binary size or bundle size in that case, and then binary size in this case would really help out a lot. All right, almost there. Yeah, so I'm hoping that this will be significantly smaller than those 20 megabytes. Um, I would also have to add in a GraphQL interface, which I can't remember what the library is called for Rust. I looked at it before, but it was a little, much like Diesel, it wasn't quite mature enough for me to be comfortable using it in production. Juniper, yeah. For one thing I gotta say is like the names are the Rust library names are definitely fancier than the Java ones, which are a little bit more no nonsense. So yeah, I'll have to check this out later, but that'll also impact the binary size. But we'll just have to see what's up. Okay, so then we're doing. We want that one. Wow, 3 megs. So yeah, that's pretty good. There's a lot of things that aren't included here yet, like the logging. There's no real like log aggregator solution in here. There's no web server or there's nothing that will actually like respond to an HTTP request, and there's no routing for the GraphQL request. But as far as like initially, this is not terrible. I do wonder like how much compression you could get out of it and what the impact would be, but I think it's a solid start. It's something to make, and I think I'm going to continue looking at this going forward. Well, anyway, I hope you enjoyed the video. If you have any questions, let me know. Otherwise, have a nice day.